The last example is a man walks 6 feet tall, walks at a rate of 5 feet per second toward a street light that is 16 feet above the ground. So the street light, sorry about that. Let me try that again. The street light is 16 feet. So here it is, and that's not changing. 16 feet. The man is 6 feet tall, so of course the ground man is 6 feet tall. We did a 6 foot tall person. I don't know why that's like super common, but the difference between this problem and the one we did in class is that the man is actually walking in this direction toward. Alright, so we know he's walking at a rate of 5 feet. So let's go ahead and label some information. The height of the pole is not going to change. The height of the guy isn't going to change either. We'll just label the distance between the pole and the guy X, and the distance between the guy and the end of the shadow Y. So the question is, at what rate is the length of his shadow changing when he is 10 feet from the base of the light? So the length of the shadow is Y, therefore we are looking for dy dt. Given then, of course, would be dx dt, which is 5 feet. And I'm going to put a negative because he's walking towards the light, which means x is getting smaller. So that's going to be important. We talked about similar triangles before. You definitely see we have a right triangle and a right triangle. So we have a big one and a little one. The big one, though, goes, the base here is going to be x plus y. So when we set that up, it should look something like x plus y over, say, 16 equals y over 6. And if you're wondering how I got that, I would draw my big triangle and show you. Here's 16 x plus y, and the little one, if I separate them, the man is 6 feet tall and y. So you can see corresponding parts. Now I kind of set mine up, it doesn't really matter, but I set mine up as doing x plus y over 16, y over 6. You could easily do x plus y over y equals 16 over 6. It actually doesn't matter because it's proportional, so it'll work anyway. And you can switch these around and it still works. It's kind of hard to mess it up. Now we're looking for dy dt. If I take the derivative of this function as it is, it's going to be really messy. I have a y here, a y here, 60. It's just all over the place. So because this is, both y's are raised to the 1 power, like something that could make my life easier maybe is to solve for y, because that's what we want anyway. So I'll cross multiply and do 6x plus 6y equals 16y, and then I can just subtract 6y from both sides. So y is going to equal 6/10 x, also known as 3/5 x. Okay, so in this case, I normally don't recommend for you to solve for the variable that you're trying to find the rate of change, but in this particular example, it's so easy to just solve and it makes your life better, so why not? Now we're gonna take the here. We haven't taken a derivative yet, so let's go ahead and do that. Remember, that's in terms of time, and that's gonna give us dy dt, which is what we're looking for. And hey, 3/5 x, the derivative is 3/5 times dx dt. And keep going down here. So dy dt, of course, will equal 3/5 times 5, or negative 5, excuse me. That's what dx dt equals. So it'll end up being -3. And our units are going to be, I think, in feet per second. Yes. So feet per second. And I'm there. Done. That's how you do this one. This one's a lot easier than the conical tank one. Alright. So that's letter A. Letter B is, at what rate is the tip of the shadow moving away from the street light at that moment? So now what they're asking you to do is to consider the distance between the tip of the shadow and the post or the street light, and to say, hey, how fast is the shadow moving away from the street lamp. And for sure the length of the shadow is changing at this rate, -3 feet per second. And the man is walking at -5 feet per second. So if you want to know how fast this is approaching this, or the tip of the shadow is approaching the street lamp, all you got to do is add the rate of change of x plus the rate of change of y, because that's the rate of change of the whole thing. In other words, take the derivative in terms of time of x plus y. And of course, that's just dx dt plus dy dt. And we already know that dx dt is -3, and we know that dx dt3 is -5, and dy dt is -3. So the tip of the shadow is getting closer to that street lamp by 8 feet per second. And that's it. All right, hope you enjoyed the videos, and now it's time for you to try some out.